looking into the code, right? So Spacy, right? Spacy API you should definitely look at. I cannot induce everything. I tried my level best. So yesterday I showed you something related to the ancestors, right? Ancestors and NER tags, right? That is a very important concept, and in real time we'll use it very extensively. So let me open that file and then talk about it. Okay. So I uploaded this file also. We have only the RNN model file. That's the only thing I need to upload, and by Saturday we'll finish it. Okay. So yesterday we started with natural language understanding, and one part of natural language understanding is trying to identify the parts of speech the word belongs to. It's called a sequence tagging because the word is dependent on the other words in the sequence. Okay. And there are sequence tagging models, statistical models. One example is hidden Markov model. I'll explain that maybe tomorrow. And the RNN, recurrent neural network, can also be used to identify the these parts of speech tags on a sequence of text. Okay. Sequence to sequence model we call it as. The language translation model is called as sequence to sequence. English sequence of words is converted to the Spanish sequence of words. So a sequence is passed in and a sequence is generated. So you can do it with statistical models like hidden Markov model and RNN also. Basically, to do all that stuff, you need corpuses, labeled corpuses. Human labels are going to help AI do the stuff. And there are sophisticated models like Spacy, Stanza, and Flare. Flare is actually picking up a lot of steam. To work with Flare, you should definitely have Linux environment. Rather, it will not work. On Windows, it will not work. It will ask you to install Visual C++ modules, but it's a headache. It expects 14 point some odd version, and you install it, it still says unable to find and all that. And I struggled with it a lot. Especially in the object detection models, when I was actually working with Windows machines only, I struggled a lot. Easier way to build deep learning models for NLP and the computer vision, Unix machine, okay, Ubuntu. Okay, Spacy works on even on that Windows machine also. And yesterday we looked at some examples of context-free grammar, CFG, right? And how exactly the CFG uses to label or find out the structure, sentence structure, label the words in a sentence, and then find out the structure of it. And I have shown you some recursive descendant parser and shift reduce parser. These are all different parsers that will actually try to understand the sentence structure according to the grammar provided by the model, whether the sentence is correct or not. If the grammar is wrong, sentence, even though sentence is correct, it's not going to show it. Again, the human label, right? The grammar is nothing but human label. And dependency parsing is a different way. It tries to look at the existing sentences. You take some sentences and specify the root word and then the dependent words, root word and dependent words. There are no, what you call it as the production rules. What are production rules? These are production rules, right? S is a variable, NP is a variable, VP is a variable, VP is a variable, and S can be started with a noun phrase and verb phrase. Noun phrase can be of a noun phrase, verb phrase can be of a verb and noun phrase, like that. These are all production rules. They are all grammatical rules, right? Shift reduce parser and recursive dependent parser, descendant parser, context-free grammar. These are all dependent on these grammar rules, and try to understand sentence structure and assign labels. But dependency parsing looks at the existing text. Right? This is also need this labeling also need to be done by human beings only. Right? As a human being, I'll read through an article or I'll read through a novel and then try to create the root words and the dependent words like this and pass that as a dependency grammar. It is like human being, right? Some people who don't know how to write and read and write can speak language well because they listened to lots of people speaking and they understood the pattern and they're able to speak, right? So dependency grammar actually looks at some of these root words and the dependent words and tries to understand the dependency between the words, and it actually assigns the labels also. Okay, so dependency grammar can understand the sentence structure and assess whether a sentence is correct or not. If you are getting multiple trees, there may be ambiguity in the sentence. If you are getting one tree, then there is no ambiguity in the sentence. That's the, so if there is ambiguity, right, word sense disambiguation models you should use. It's a research area and there are problems in it, and I don't know, maybe some enhancement might have happened most recently. Try to look into Google on word sense disambiguation, word sense disambiguation, and try to read through some articles. Okay? Currently we are in a place where we should be looking into research papers. Okay, because I told you that we built a speed detection model, right? That was actually an outcome of a research paper. We looked into multiple research papers and found in one place that the solution, and we programmatically implemented that. That's an idea, we implemented it. And there is more advanced ideas in the speed detection. There is a concept called a 3D bounding box. You know bounding boxes, right? Do you know bounding boxes?
Yes, sir.
I'm just trying to, show you. These are bounding boxes, right? Right? We actually take, if you have time, right? If you want to involve in our project, right? I will show you how exactly we did that model and where that help is needed, because that's a real time thing, right? So if you have to build something somewhere, it will be useful. Okay, there is a concept called as 3D bounding boxes. This is a research area we were actually trying to do, but we did not get time, right? So for a car, see this is a 3D bounding box. Can you see the screen? See, this is a 3D bounding box, right? So what is the advantage of 3D bounding box? You already know how much space it is occupying. In a two-dimensional, 2D bounding box, right? You will not be able to identify object dimensions. When you don't know object dimensions, right? How far it traveled, you don't know. When you don't know how far it traveled, even though you know the time it took, you will not be able to calculate the speed, right? So if you know 3D bounding boxes, right? In any area you can calculate speed. Right? The model we built right now, we have to know the physical dimensions on the road. Rather, we'll not be able to calculate it. That's a drawback in our model. If you know 3D bounding boxes of each object which is traveling on a road, okay, you can find out the speed of a vehicle any place, anywhere, any place, and you can actually assess the distance it travels also. To build a robo, right, you need 3D bounding box. Okay. This is the next research item we are handling. One more item we are handling is, we are going to handle is so Jetson, this is like, have you heard about Raspberry Pi? Raspberry Pi you heard, right?
Yes.
Right? Like that, it's a edge computer. They call it as edge computer. This will have NVIDIA graphic cards. Okay. So we have to actually migrate our code to NVIDIA graphic card, these kinds of edge computers, because we should be building a module like a box, which will have camera and this, edge computer, everything, as a single module. We will deliver it and we'll fix it on a pole, and it will actually, do whatever, right? So this is needed when, where there is internet is not that cheap and not that fast. Then, right, everything will get processed in the computer itself, and only images and the text data will be transmitted to the server, right? That's the next challenge we are actually trying to handle. And there are other challenges also in the current current model itself, but these are the major challenges we are going to handle in future. Okay, why did I tell that? Is like, we should be looking into papers, right? If I say word sense disambiguation, you will see many articles, the research papers published on it. You need to read through them so that you will get some ideas. Maybe you will experiment one or two ideas and it may work in your real-time project. Okay, so the people who are working on AI projects should definitely look into research papers and try to implement. In every AI project, there will be some place where you need to do research. So you should educate the client and then take the time and do research. Then only we grow. If you are not learning anything while working, no use of working anywhere. That's what my feeling is. Okay. No, I was actually working on Java, and the web application frameworks. A time came in when I had to actually learn Angular JS and React JS, that stuff. I thought it is not a new thing I am learning. It's whether you do a JSP or a servlet or a or a JSF or any web page. It is just a web page, a new technology. Somebody else built a framework and you are trying to do that. I felt that is not a new thing, so I just kind of tried to change my area. Because if you are not learning something new, right, there is no excitement in working. That's what I feel. So when you are working in a project, you should always try to make some room for research and then try to do it, and it may succeed, it may not succeed, but we should save our job. Parallelly, we should increase our knowledge also. Okay, try to spend some time on reading the articles. Okay, maybe I would have covered something, may not have covered something. I cannot cover everything. I don't know everything, right? So you try to spend some time, okay? And then Spacy we have taken, and then I created a language model, instance of a language model. Right? My mouse is not working. So instance of a language model, and passed my string to that language model, and it outputted, right, whatever that see this here, Apple, and then it's actually tagging the dependency parsing. It is okay. It is actually, it identified this 1 billion as a number. See this here is a symbol. This is a number. Billion is also a number. When we were doing initially the using the NLTK tokenization and stuff, right? It was not able to identify these things, right? So Spacy is able to identify numbers also, right? Named entities it is identifying. Okay. So the task I was actually about to perform in one of the organizations I joined and left was the named entity recognition. We need to identify the different entities, the doctors, the drugs, devices, and documents and all that. Okay, so the model should be intelligent, not if else conditions. Okay, unfortunately, that's what happening there. So I thought it's not my cup of tea there. So that's okay, right? So here, right, I actually tried to show some example here of a travel domain, right? I am traveling from Hyderabad to Bangalore. If this is a chart, this is typed in a chat window. The chat bot should understand from where to where the person is traveling, and accordingly it should show tickets or the flights. So to identify that, I took the named entities and their ancestors. If the ancestor is to and from for the named entity, right, if you look at this, the named entities, the locations are Hyderabad and Bangalore, right? In the named entity, you will GBP or something, a tag, right? and the ancestor to Bangalore is to, right, traveling, right, and to ancestor for Hyderabad is from and traveling. If you have from and traveling, definitely that's the source and that's the from to and traveling, that's the definitely destination. So you can write some logic around these tokens. See, NLP or the language model is giving you some clues or assign some labels and giving you some clues where you can programmatically understand the source and destination, do appropriate query from the database, bring out the data and show it to the client. Got it? Did you understood this block? This block is important.
Yes, sir. One question, sir. So this dependency parser, what you mentioned, basically the output of that is giving us some tokens and ancestors.
Yes,
This
sir.
is what is the output from the dependency parser, sir?
Yeah, let me explain that. That's a good question. Actually, I mixed up everything and explained. Right? Let me try to show you the pipeline. So give me 1 second. In Spacy, there is a processing pipeline. Okay. What is the processing pipeline? Is it does multiple things. It does POS tagging. It does the dependency parsing. It does named entity recognition. All are useful. See this pipeline, right? It tokenizes, then tags the POS tags and parses dependency parsing. It does. It does NER. There are other components also in pipeline. Tagger, lemmatizer, and then text categorization. Assigns categories to each text, and custom modules also. You can actually give custom components, right? Like this doc underscore function. You can write functions also. Okay. So I will not go into that depth there. You can. It is easy only. If you look at the documentation, you will understand. So NER tagging will let you know whether a particular word is a geographic location or a office or a drug or device or whatever, right? But the POS tagging will tell you what is the parts of speech that the word belongs to. Okay. And dependency parsing will tell you what is the subject, what is the object, Dependency parsing is a kind of grammar which actually tries to tell you the subject object kind of a thing. Okay. So, you are actually trying to understand. There is a hunter who actually shot a elephant or a deer, right? So you want to understand who so Rama shot a deer in a forest. So there is a subject, there is an object, right? So shot is a subject, I think. The deer is an object, and the Rama is a some kind of If you know that English well, right, you can actually write logic around it and find out which was shot by whom. Okay, the other way around is if you know the named entities. Deer is a named entity. Rama is a human named entity, and gun is a named entity. Shot is kind of a verb. That the POS tags, dependency parsing labels, and NER labels will give you a clue on finding out the result you want to extract from the text. Got it? That's what I was actually trying to show here.
Yes, sir.
Did I answer your question, sir?
Yes, sir. You did.
So it is not independent. There are actually independent modules there which are doing all the components there, but they are not independent. When it is coming to a task that we need to perform, we may have to use all. Most of the times we'll use NER tags. Okay. So to train our custom model, we may use the POS tags and dependency parsing tags to specify the NER tag. So the sky is the limit. You actually have to use different combinations there and make the task performed, right? Whatever the given task you have to deliver, you have to deliver that. Okay, there is facility given by the model. Will it work for all the data and all the use cases we are going to work? No. So for some it will work. For some we have to customize it. I'll show customizable NER tagging model. Okay. So this is simple example I have given. On a travel domain, if you have to build a chatbot, so we will not build chatbots our own, right? We will use either Google Dialogflow. Right? This is very easy to learn. Try to spend some time on Dialogflow. It is free. You can build a chatbot maybe in an hour. Okay, in just 1 hour you can build a chatbot which actually can understand speech and text both. On our website, whatever chatbot we built is using Dialogflow only. There is another module called as Rasa. Right, this is a customizable module. There is a lot of framework around it, and you can actually, build your own custom deep learning models and place them in there and all that. Okay, this is customizable. You can download it and you can build on your, you can actually train the model and make your own thing on your own server. Why is that needed? A banking domain may never want to use Google Dialogflow or Amazon's chatbot service or Microsoft's ML chatbot service. So you have to build custom models which will be deployed into their own servers or private clouds, right? So looking into Rasa is also important. So you can do that later also, but to build sophisticated chatbots, you should look into Rasa. And there is a concept called as intent identification. So here we were actually trying to understand the intent. Okay, so intent, what is the intent? Purpose. Okay, so determine to do, right? So what is the intent here? Somebody is traveling from a city to another city, right? From and to which city to which city, that is the intent. So to do intent identification also we can use Rasa. No need to write this kind of a manual code. Very rarely we may write, but if you understand these kinds of tools, right, you can actually do it with ease. Okay, I also have to explore a lot in this. I did maybe 20% of exploration there. I never got time, and my problem is that until and unless I get a requirement and somebody is pushing, I'll not do it. And time is also not sufficient for me, so I never did that. So if you get time, right, try to look into Google Dialogflow first and then Rasa next. Okay. To do a chatbot, you can use those tools. Okay, and then right. So you can actually do, see this, I'm actually trying to do some custom, let me try to run this. Okay, so I have taken this sentence is another sentence, right? Sentence segmentation is a concept, right? We did word tokenization, right? We took words as separate, entities, right? Like that, sentences also we may have to segment sometimes. So generally, the Spacy's default sentence segmentizer will take full stop as the sentence, right? End of the sentence. Okay, but you can have your own sentence segmentation also. Right? Set custom boundaries is the method. Right? In the pipeline, NLP is the module, right? Sorry, model, the language model. In that language model, I showed you some pipeline here. Where is the pipeline? Yeah, there is pipeline, right? You can add a module in between, custom module in between. See this, I am adding that here. So I have created set, custom boundary, boundary, and I did taking doc as the input. And for tokens, in beginning till end for all tokens, and I'm printing the token and printing the index of the token. Token.i is going to print the index. If token.text is equal to 3 dots, right? Sentence start is going to true. I kept. That means a new sentence started. That's what I'm trying to do here. So let me comment these two out and then run this. These two print statements I'll comment and then run. Code error. New version changed. Add pipeline name instead. Create pipeline name. Okay. I think they changed the name. Before. So before where, let me look at the API, these guys changed it. That's the problem with AI, right? I wrote that code 6 months back and they changed it. So in production also you'll have these problems. I think dark underscore what. So where exactly we should add it? Create pipeline string name. Now, before which we should specify in the pipeline, right? Should we should we execute our method, our custom function before parts of p tag or after parts of p tag or before ner or after ner? We should specify. That's what I'm actually looking at. So this guy actually kept this info at the last is equal to true. Before first true. Right, add the component first in the pipeline by specifying first true. You will see the parts of speech tag are empty. Right, name pipeline names and info. Maybe I'll put it at last. Last is equal to true. So add pipeline component. This is the syntax. They changed. Huh? Add pipeline is there, right? Add pipeline is there. Add pipeline is there. Why is it throwing error? Let me try to put it here. So I'm trying to induce custom modules there, Custom, what the heck? Cannot find factory for set custom boundary. This is changes syntax. My component, where did you use my component? Info component. Let me try to put this here. No need of annotation there, but custom sentence either. These guys change it before parser. What? Let me take this. These guys change it, and I think I have taken it from here only. Right here. Yeah. Yeah, documentation is very, very clear. I would have done something mistake, something wrong there, but it worked before. Maybe these annotations they made it as compulsory. If I take out this annotation, it may not work. Let us see. No, it's working. Annotations are for documentation, I think. Previously, it did not work. Why? SM model, add pipeline, NLP, instances. I don't know. I couldn't see any difference in there in the code I wrote and these guys wrote, but that's okay, right? You can actually induce, induce your own custom modules before parser it is. Right? After parser also you can induce. So you want to do your normal activity and then you want to apply this also, you can do that. Right? Your own code you can induce into the pipeline of Spacy. Got it? Got it? Any questions? Did I confuse you? Good.
Yes, sir.
And then, right, named entity recognition. See this? In this particular text, right, FB is looking at buying UK startup for 1 billion. Right? I took that sentence and tried to do the named entity recognition and render, display.render will actually do this kind of highlighting. This is just to play around, but it's not going to be useful in production, right? So the style is equal to entity, right? Entity style it's going to do. So if you look at this text, right, it identified UK as a named entity and it is saying GPE, that means it's a geographical location, 24 to 28, $1 billion, 41 to 51, it's a money, right? So it identified, but FB did not identify. Facebook, right? FB is Facebook. So let me take another string. San Francisco considers buying sidewalk delivery robots, right? Sidewalk delivery robots. So if I try to do entity recognition, right? See, this San Francisco was identified as one entity. In the beginning of the NLP class, when we were doing tokenization, San was separate and Francisco was separate. But this the Spacy is able to identify San Francisco as a geographic location, right? So the problem we are facing now is FB is a custom word to specify Facebook. We should identify FB as a named entity. Can we do that? Yes, we can. Okay, we can do a custom model. Custom, we can actually specify whether. Yeah, this is nothing. Yeah, from the doc, right, you can actually take the text, right, and then that that text, right, has got tokens. I said, right? Do you remember? Doc has tokens. Do you remember? Each doc has tokens. Do you remember? Right? 0th token is San. Right? First token is Francisco. Second token is but for each token, right, there is a entity labeling, right? Entity IOB, right? Entity IOB, entity type. Let me try to execute this and see. Maybe in the new version it would have changed a little bit. Let me try to execute. Right, so see this doc 0 is the first token, doc 1 is the second token, right, in the text. So these are all the tokens. But for each token, right, there is a IOB notation. IOB means inside, outside, or between. Okay, San Francisco is a entity. In that entity, San is between, Francisco is inside, and considers is outside. Right, it is not a named entity, but it is outside the named entity, whatever. Right, that this IOB notation will actually show you whether a particular token is inside or between a named entities or not. There may be a named entity with maybe 5 words, but all those 5 words, where exactly that particular word is between, or at the beginning or at the end or whatever. That's That's the IOB notation we call it as. Okay, that's another concept we need to understand, but I never used it anywhere. Okay, so here I am doing custom, named entity recognition training. I created training data, right? And then I specified where exactly the entities are present. Entities are present from 0 to 4. Uber is an entity, organization I specified. Google is an organization I specified. FB is an organization I specified. And I took small model and I started training, and then I took 200 iterations, right? I shuffled the data. Here I took a simple data set with 3 rows, but in real time, right, you take 300 or maybe 30,000 records. You need to farm this data. To farm this data, there is a tool called as Prodigy. I'll show you in a moment. Okay, so we shuffled it, and then I took the training data. In this training data, right, the text and the annotation. This is text, this is annotation, right? Annotation is the dictionary. If you have multiple annotations, you can specify multiple annotations also, right? Entities, in that list of tuples where beginning, end, and the named entity tag we call it as, right? We are updating the model with this. Okay, and SGD is the optimizer. Where is the optimizer? Did I select optimizer somewhere? Yeah, here. Okay, begin training is the optimizer. So stochastic gradient descent is the optimizer inside. Okay, and then we are saving the model. We can use this model, and now if I run, right? Oh my goodness, gone. These guys changed it, I think. Maybe I should take EN model. Blank model I'll load, and then I'll try to do it. These guys changed it, that code was working before, and yeah. English is not one of this. I think it is there on top. We can load a blank model, and then what the heck is happening here? Was called with the 2 positional arguments. So change the format and data. The update function should now be called with a batch of example objects instead of. Okay, that's okay. Maybe I'll just comment it, and then I'll just pass this train data directly. These guys change the structure. Not working. List of example objects, but got a tuple. I think these guys changed the structure also. So okay, so the structure is changed, and maybe I'll look at it and explain tomorrow. But if you I showed you this, right? This data need to be formed like this, right? Formatted like this. This can be done using a tool called Prodigy. This is a paid tool. Nobody is interested to use it in the organizations, but it's a paid tool. Let me show you that. If you run this example, where is that example? Yeah. So if you upload a document into this Prodigy tool, right, it will give you an option to highlight the text like that, and then select the see that I highlighted it, and then I can specify it as a not a person, date. Okay. I selected date and then highlighted, right? It actually identified that as a date, right? If I selected organization, then specify Apple, it will write like that. At iPhone, the product, right? It's a product. I can select it, right? And then if I say yes, right, and then I can, yeah. So in this tool, right, we have this kind of an option. It's a application where you can actually highlight and create this kind of data and pass it to the model to train. I read a big example here. Let me execute this and see. Salman Khan, a person. Is it working? PLEC now. This I need to install. Give me 1 second. I don't know for what.
Sir, I have another meeting. I'm leaving, sir.
Yeah, okay, sir. Okay, sir. So I think I'm almost done. I'll explain this anyway tomorrow. Thank you, sir. Thank you. Yeah, I'll explain this tomorrow. There is no change in the API, and I need to look into the API and correct it. I'll correct it and show you tomorrow. Okay. So that's it. Any questions you can ask.